Okay, in this video we're going to have a look at some exact values of our circular functions. Now you've actually seen some of these already in some of our previous work on the unit circle, okay, and we know that we get some exact values from that. Okay, so remembering for any point on the unit circle, xy, point xy, the x is equal to cos of theta and y is equal to sine of theta. Okay, so using that knowledge, okay, we can pull out some exact values of specific angles. Namely, we can pull out here, okay, at our angle of 0 radians, okay, we see that cos is equal to 1, sine is equal to 0, and remember, tan is equal to sine over cos. Okay, so get 0 divided by 1, which is 0 for tan. Okay, similarly, if we keep working around and we get up to here, that's when we get pi on 2. Okay, so in this case, sine is 1, cos is 0. 1 divided by 0 is undefined. Oh, sorry, I put that in the wrong spot. 1, 0, and undefined. Okay, and that's because our tangent here to our unit circle is parallel to our vertical axis here. And if you want more detail on that, check out one of my previous videos. Okay, similarly though, keep going around when we get to pi radians. So we've come around to pi on 2, now we're coming around to pi radians. Okay, we see that sine is going to be 0, cos is going to be -1. Okay, so then we get tan value of 0. Okay, when we get around here to 3 pi on 2, right, we see that sine is -1, cos is 0, and once again tan is undefined. Okay, but how about in between? Okay, we've only gone at these key points, right? And there are some other angles, okay, for which we get exact values. Okay, they're nice numbers. Okay, by nice, they're still surds, okay, but they're not too difficult to work with. Okay, our first one is pi on 6, okay, then pi on 4 and pi on 3. All of these values gives us nice values for sine, cos and tan. And the way we can work them out is using these couple of really useful triangles, okay, which I've drawn here. So this first one, okay, we've got a right angle triangle, we've got an angle down here of pi on 3, okay, we've got an angle up here of pi on 6, and our side lengths must be 1, 2 and root 3. Right, our second one here, we've got a right angle triangle where both of our angles are pi on 4. Okay, remember pi on 4 is 45 degrees. Okay, so our angles must be the same then. Okay, and we've got sides of 1, 1 and root 2. Now using SOHCAHTOA, okay, we can work out the exact values for these. So if I look at pi on 6, I want sine. Well, sine is opposite over hypotenuse, so that's going to be 1 on 2. Cos is adjacent over hypotenuse, which will be root 3 on 2. Okay? And then tan is our opposite over our adjacent. Okay, so we're 1 on root 3, which is also equal to root 3 on 3 if we rationalise the denominator. Okay, if we look at pi on 4, that's this triangle here. Okay, then it doesn't matter which angle we work off here, okay, because they're both the same. For sine, it's opposite over hypotenuse, so it's 1 on root 2 or root 2 on 2. Okay, cos is the adjacent over the hypotenuse, so it's also our 1 on root 2, which is equal to root 2 on 2. Okay, and tan is our opposite over our adjacent, so it's equal to 1. Okay, if we look at pi on 3, okay, and I've just done these in ascending order here. Okay, that's why we're having to switch across some triangles a little bit. Okay, if I look at pi on 3 now, that's our angle here. Sine is our opposite over our hypotenuse, so that's root 3 on 2. Okay, then we have our cos, which is our adjacent over our hypotenuse. That's our 1 on 2. Okay, and then tan, we're going to have our opposite over our hypotenuse, which is just root 3. And notice we've got a bit of similarities here. Okay, we had this value of a half of pi on 6 for sine, okay, and root 3 on 2 for cos. When we're looking at pi on 3, those values have changed. Okay, we'll switch those ones around. And these ones are the reciprocal of each other as well. Okay, and sine and cos obviously had the same value here. Okay, so that's the idea of what we need to do here. Okay, and all we're doing for this section, okay, is utilising that information. Okay, however, there's a little bit more to it than that. Okay, because we need to know about what quadrants we're in. Okay, so I'm going to switch over here. I'm going to draw another unit circle. Okay. And for example, we're going to have a look now at some of our values that we could have. Okay, so this is our unit circle here. I'm putting on cast. So that's the other piece of the puzzle here. Because, for example, you could be asked, what is sine of of 2 pi on 3? Now, what you need to think about that is go, okay, well, how do I get to 2 pi on 3? Okay, well, this is pi on 2. 2 pi on 3 is bigger than that. Okay, but it's less than 1 pi, which is over here. So I'm in this second quadrant. Now, remembering from our previous work, our angle in our second quadrant, if I flesh this out, okay, it's pi minus theta. Okay, so really what we're saying is that this is equivalent to sine of pi minus theta. And you go, well, what have we had to take away from pi to get to 2 pi on 3? Well, we can see that that means that theta equals pi on 3. Okay, now we think about our exact values. Okay, for pi on 3, we're utilising this triangle, because our pi on 3, pi on 6, okay, 1, root 3, and 2. Okay, so if we're looking at pi on 3, we're looking at pi on 3, sine is opposite over hypotenuse. Okay, so sine of pi on 3, okay, is root 3 on 2, our opposite over our hypotenuse. Okay, but this is where we need to include cast though. Okay, which is telling us, okay, that we're in the second quadrant here. Okay, because we're 2 pi on 3, that puts us in the second one, so we're going to have a positive value. Okay, so we can go, therefore, sine of 2 pi on 3 is also equal to root 3 on 2. Okay, so remember this angle up here that we worked out, this theta, this is what we call our reference angle. We always need to work on our reference angle. Okay, once we worked out what our reference angle is, then we can work out what our numerical value is, okay, and then use cast to work out whether it's positive or negative. Okay, so we'll do another one here. Okay, let's go for something like 10 of 3 pi on 4. Okay, so again, we can see we're outside the first quadrant, so we need to work out our reference angle. Again, okay, when we look at 3 pi on 4, that must mean that we're actually in the second quadrant here. Okay, our second quadrant is pi minus theta, so we can say pi minus theta equals 3 pi on 4. So theta must equal pi on 4, and that is again, our reference angle. So we found that reference angle. So now we actually take our value of 10 of pi on 4. Okay, and for that one, we're using this triangle, which is our pi on 4 triangle, which is 1, 1, and root 2. And 10 is offset over adjacent, so it's just 1 on 1, which is 1. Okay. However, now we need to use cast. Okay. When we look at quadrant 2, sine's the only one that's positive. Okay. So we know, therefore, that 10 of 3 pi on 4 is going to equal negative 1. Because it's going to have this value of 1 that we found. Okay, but because we're in the second quadrant, it's going to be negative. Okay, we'll do one more. Okay, let's go to a different quadrant. This time, let's go cos of, let's go for 5 pi on 4. Okay, so now we're going, okay, how am I working out this? Well, you need to be thinking, where's 5 pi on 4 going to be? Okay, well, it's going to be bigger than pi, okay, because pi is 4 pi over 4. Okay, so it's going to put us in the third quadrant here. Okay, we're in the third quadrant. Okay, so now in our third quadrant, we get our angle by going pi plus our angle equals 5 pi odd 4. So if we take away pi, we're going to get theta is equal to pi on 4 again. Okay, we say cos is negative in third quadrant. Okay, because we go cast t. Okay, so tan's positive, everything else is negative. So we go therefore. Okay, so we know that, sorry. So then we go cos of pi on 4 equals, well, we can use our triangle here. Cos is adjacent over hypotenuse, so 1 over root 2. Okay. Therefore, cos of 5 pi on 4, we're going to bring it all together now. Okay, we know cos is negative, and we know our value that we get is 1 on root 2. Okay, so what's the process for solving some of these? Okay, we need to identify two things. One, our reference angle. Okay, and two, what quadrant we're in. Okay, so we look at what quadrant we're in. Okay, identify how we find our angle. Okay, remembering that our angle in the first quadrant is just our angle. Second quadrant, pi minus theta. Third quadrant, pi plus theta. Fourth quadrant, 2 pi minus theta. Okay, so we identify what quadrant we're in, okay, and what our reference angle is. We then take either sine, cos, or tan, whatever the question is asking us for, of that reference angle. Okay, then we're looking at which function is positive based off cast, okay, to get whether our final answer will be positive or negative. Okay, so hopefully that'll be enough to get you through this. So I just realised I've gone off camera slightly with those. Okay, but hopefully that will be enough to help you out with some of these questions.